Video 6 is our last video in the series for Unit 1. In this video, we will cover how to do factor label or dimensional analysis with conversion factors to solve problems and to check to make sure that our values make sense. So many activities in the laboratory and in medicine require converting a quantity from one unit to another. And we do this by using what we call the conversion factor. Conversion factors are numerically equal to 1. And if you remember when we looked at converting between metric prefixes, I mentioned that when we have this type of equality, they're equal to each other. And when 1 kilometer is equal to 0.6214 miles, a number divided by itself equals to 1. So we can use a conversion factor in doing calculations because it's just like multiplying that number by 1. Again, we also took a look at how we can rearrange these values. I can put the kilometers on top, the miles on the bottom, or I can put the miles on the top and the kilometers on bottom. Both of them are numerically equal to 1. When we're using these conversions, it all depends on what our final unit must be, how we're going to write the conversion unit, what unit goes on top and what goes on the bottom, since they're all equal to each other and equal to 1. Again, these links are clickable for you to check and go to tutorials or other videos to help you with this information. What are some equalities that you frequently use but never thought of as conversions? How about a dozen? How many eggs are in a dozen of eggs? How about a pair? How many shoes are in one pair of shoes? So any equality can be written as a conversion factor. So if we have 60 minutes in 1 hour, then we can write 60 minutes per hour, or we can say 1 hour per 60 minutes. We already looked at metric equalities. If we have 1 meter that is equal to 100 centimeters, then I can write 100 centimeters per 1 meter, or I can write 1 meter per 100 centimeter. All of these conversions are equalities, and they equal to 1. So units are treated like numbers, and we can multiply and divide the units. We set up every equation so that all the unwanted units cancel. We are always going to start with the amount of given in our question. For example, how many kilometers are there in 26.22 miles? Well, my question is, how many kilometers? To set up this problem, we're always going to start with what we were given in the question. We weren't given the kilometers, but we were given the miles. So I start with what I'm given, 26.22 miles. On a few slides ago, we talked about what the conversion was between kilometers and miles. Since I want to know kilometers, I'm going to set up my conversion so that kilometers are in the numerator and miles are in the denominator. So this is our conversion factor. Our units are going to be canceled because I want kilometers in my answer. I'm going to cancel out my miles and I end up with 42.20 kilometers. My final value is based on the number of significant figures in my given amount and not on the number of sig figs in my conversion factor. Here we have a table of metric US and metric US units. You also have a table very similar to this in your reading materials. You will not be required to know differences between US and metric units, although it might be useful for you to memorize some, such as centimeters to inches and kilograms to pounds. The highlighted values are the ones that are most often used in medicine. 1 millimeters is equal to 1 cc. 1 milliliter is 15 drops. 5 milliliters is equal to 1 teaspoon. 15 milliliters is equal to 1 tablespoon. And 1 milligram is equal to 1,000 micrograms. This is slightly different than what we use for micrograms in chemistry. We use the symbol called mu instead of writing MC. How do we go about solving problems using unit conversions and estimating our answers? First, you identify the information that is given, including the units. Number 2, identify the information needed in the answer, also including the units. Find a relationship between the known information, the unknown answer, and plan a series of steps from getting from one to the other. Next, solve the problem. At the end, well, prior to that, you can make a ballpoint estimation at the beginning to check your final answer to make sure your value and your units are reasonable. So let's do a little bit of practice to see what are the conversion factors for the following pairs of units. Well, for A, we would just check the table. And when we look at the table on the previous slide, it said that there's 1 pound for every 1 gram, or for every 454 grams, or 454 grams for every pound. For B, we need to do a little bit of dimensional analysis. If you remember from our video on metric conversions, we went from the prefix unit to the non-prefix unit to the prefix unit. Or you can draw a number line in order to go from one unit to the next. So 1 deciliter is equal to 0.1 liters, and 1 milliliter is equal to 0.01 liters. So if we do a little bit of a dimensional analysis, we can say that 1 deciliter is equal to 100 milliliters. So we've got 0.1 liters. We get that from this equality here, times 1 milliliter divided by 0.001 liters. And that gives us 100 milliliters. If you remember the number line, 10 to the minus 3 is 2 hops away from 10 to the minus 1. So that means that I would need, if I'm going 2 hops to the right, my number is getting larger, so that would be 10 to the 2. And 10 to the 2 is equal to 100 milliliters. So let's go back to our conversion between deciliters and milliliters. 1 deciliter is equal to 100 milliliters. So that would be 1 deciliter divided by 100 milliliters, which is also equivalent to 100 milliliters divided by 1 deciliter. Let's do a little bit of practice. A child is 21.5 inches long at birth. How long is this in centimeters? Well, first, identify the given information. We've got 21.5 inches. The length is 21.5 inches. Let's identify the answer and the units. Our answer has to be in what? Correct. It's a length and it's in centimeters. So we want to know how many centimeters. Identify the conversion factor. Here, we know that 1 inch is equal to 2.54 centimeters. Now we're going to solve. You're always going to start with the given value. We were given 21.5 inches, and we're going to write our conversion so that our centimeters are in the numerator and our inches are in the denominator. So when we do the math, we're going to maintain the same number of significant figures in our given value, and we're not going to use our conversion to help us determine our final answer. Let's do a little bit more practice. A one-step conversion factor. If Greg weighs Let's do a little bit of practice. We've already done a simple one-step conversion factor. Let's try another with multiple steps. Synthroid is used as a replacement or supplemental therapy for diminished thyroid function. A doctor's order prescribes a dosage of 0.150 milligrams of Synthroid. If tablets in the stock contain 75 micrograms of Synthroid, how many tablets are required to provide the prescribed medication? This is also a dosage calculation as well. So all dosage calculations can be considered conversions using dimensional analysis or the factor label method. So what are we given? We're given that we have 0.150 milligrams of our substance, and we also have that it's 75 micrograms per tablet. We want to know how many tablets we need to give of this substance. So to solve the problem, we're going to write out each step all together in one. I'm always going to start with the amount that I'm given. Now, you might think to start off with the 70 micrograms. The reason why we don't start with that is because that is our conversion, because it's 75 micrograms per tablet. That is in a fraction. So we're always going to start with the measured amount, 0.150 milligrams. This is what we're starting with, times 1 tablet per 75 micrograms. However, we have milligrams, but we need to get to micrograms, right? So we have our milligrams, we have 1 tablet per 75 micrograms, but when we do this calculation, we don't actually end up canceling out milligrams. So we have to do one more step. We have to include a metric conversion. So 1 milligram is going to be equal to 10 to the 3 micrograms. 10 to the micrograms, excuse me, are 10 to the minus 6. So there are 3 hops to get from micro to milli. Our milligrams cancel with milligrams, our micrograms cancel with micrograms, and we're left with tablets as our final value. And our answer is 2 tablets. Whenever you're doing dosage calculations, make sure that your answer makes sense. 2 tablets, tablets are whole values. You might be able to do a half of a tablet, but not a 2.89 tablets. So you would round up a value of 2.89 to 3 tablets. Let's do another dosage calculation. A bottle contains 200 milligrams of cough syrup. If 1 teaspoon or 5 milliliter is given 4 times a day, how many days will elapse before a refill is needed? Let's think about this. What are we given? We're given 200 milliliters of cough syrup. And what's our conversion factor? We'll get there in a moment. How many days will elapse before the refill is needed? That's what we need. We're given a conversion of 5 milliliters 4 times a day. So let's write down all the information that we have. We have 120 milliliters of cough syrup, and we have 5 milliliters times 4 times a day, which equals 20 milliliters per day, right? Makes sense that if we're given 5 milliliters 4 times a day, how many milliliters are used in a day? 5 times 4 gives us 20 milliliters used in a day. We want to know how long will it be before we need a refill? That's the number of days. So how many days? We're starting with our given value, which is 120. So if it's 120 milliliters times 1 day divided by 20 milliliters, that's our conversion factor, right? 20 milliliters is used in 1 day, then 1 day per 20 milliliters gives us 6 days. In 6 days, we would need a refill. Let's do conversion units looking at density as a conversion. What is the volume of a gold nugget that weighs 2.2 kilograms? If we're given the density of gold is 19 grams per cubic centimeter. Notice that we have 2.2 kilograms, but our density is in grams. So that means that we're going to have to do a conversion from kilograms to grams in order to determine our volume. So what are we given? 2.20 kilograms. And we can do that conversion right now without having to do any math, really. So whenever we're going from kilograms to grams, we're going to move our decimal place to the right. How many spaces do you think? Remember, kilo means 1,000. So if I multiply 2.20 by 1,000, that's simply me moving the decimal place over to the right 3 spaces. 1, 2, 3. So that's equal to 2,200 grams. We're given our density, that is 19 grams per cubic centimeter. We need our volume in cubic centimeter. If there's no specific units that are requested in your problem, you use the units that you have in your conversion to give you your final answer. So we need to rearrange this equation to give us the volume. So volume is going to be equal to the mass divided by density. So we would multiply both sides by the volume, then divide both sides by the density, and we get V equals M over D. V, what does V represent? Volume. M represents mass, D represents density. So here we go again with this M. It represents mass, and it represents the M for meters, and it also represents milli. So you have to recognize where this M is located in order to determine what it means, right? Because it can mean milli, it can mean mass, and it can mean meters. Here, we know that it's meaning meters because it's headed off by a C. And we know that it's centimeters cubed. And we know that centimeters are a distance, but because it's volume, length times width times height, we get centimeters cubed. So we just take our given amount, 2,200 grams divided by 19 grams per cubic centimeter, and we get 115 centimeters cubed. Remember, we're always going to keep the sig figs in our given value and not our conversion. The density here was used as our conversion. We don't use it in our calculation. One more. How many liters of fat would have to be removed to result in 4.0 pounds of weight loss if the density of human fat is 0.94 grams per milliliter? Pause. What are we given? We're given that we have 4.0 pounds times 1 kilogram divided by 2.20 pounds. That is our conversion factor between pounds and kilograms. Our next step would be now to convert our kilograms to grams. And we know that for every 1 kilogram, we have 1,000 grams because kilo is equal to 1,000. This gives us the number of grams that we have of the substance. Now, we're going to round off to 2 significant figures here because we started with 4 pounds of weight loss. Now, this is just the mass. All we've done here is converted our pounds, which is a weight, into grams. But we want to know how many liters of fat will have to be removed. So this is where we're going to use our density. So our density is 0.94 grams per milliliter. Now, our question is telling us that we need our volume in liters. So notice that for this problem, there are a number of conversions that must be done before we get to our final volume. First, we had to convert from pounds to grams. And now we're going to use that information to determine the volume based on the density. So again, volume is going to be equal to mass divided by density, which is 1,800 grams divided by 0.94 grams per milliliter. And we end up with 1,914 milliliters. Well, remember, we had to round off our first amount to 2 significant figures. Pause. Escape. Let's do a little bit of practice taking a look at using conversion factors such as density to solve problems using multiple steps. So the first question says, what is the volume of a gold nugget that weighs 2.20 kilograms? The density of gold is 19 grams per centimeter cubed. We are given that we have 2.20 kilograms. Our density, however, is in grams per centimeter. So we can't particularly figure out the volume of gold directly from multiplying kilograms to, by 19 or even divided by 19. We have to convert this kilograms to grams. Let's do that first before we get started with our problem. When we're looking at this 2.20 times kilograms, it's essentially saying that 2.20 times 1,000 grams is going to give us 2,200 grams. How do we quickly go from kilograms to grams? Move the decimal place over 3 spaces to the right, 1, 2, 3, to give us grams. If we want to quickly move from grams to kilograms, you just move the decimal place to the left 3 spaces, 1, 2, 3, and we end up with 2.2 kilograms. Now that we've done that, we also know that we're given our density, which is 19 grams per centimeters cubed. We need our volume in centimeters cubed. Now, when we look at our density, we see that D is density, M is mass, V is volume. You might get confused sometimes when you see this M in so many places. In this place, the M is representing mass. Here, in this unit, cm cubed, the M is representing centimeters. At times, if you see M before another letter, that is going to indicate milli. But let's get back to our problem. We want to find the volume. Volume is going to be mass divided by density. And so we take this newly calculated mass, 2,200 grams, and divide it by 19 grams per centimeter cubed. When we cancel out our grams, being that centimeters is in the denominator of a denominator, it moves up into our numerator. When we do this math, we get 115.789. Now, our starting value has 3 significant figures, so our final value also have to be 3 significant figures. What do we round this problem off in order to get the right number of sig figs? You're right. Let's look here. We have to look at this 5 because we're starting 1, 2, 3 sig figs. We look at this 5. The number to the right of it is greater than 5, so we're going to round this up to 6. So we end up with 116 centimeters cubed. Remember, you do not use a conversion factor such as density to determine the number of sig figs. Let's take a look at this next question. This question has multiple steps, and sometimes you have to do a number of conversions before you can get to the final value. So this question says, how many liters of fat would have to be removed to result in 4 pounds of weight loss if the density of human fat is 0.94 grams per milliliter? Well, we're given 4 pounds. We can't necessarily calculate directly 4 pounds. We know that's a weight. We have to get that into a mass before we can calculate our volume using the density. So let's go ahead and convert this now. Based on the conversion factor that we saw on a few slides ago, we know that 1 kilogram is equal to 2.20 pounds. We also know that we can't stop at kilograms because our density is in grams. Well, 1,000 grams is 1 kilogram. Our final value here is going to be 1,818 grams. We are not going to round off this value here. we're going to hold on to all of these places, although we know that if the question was asking for the mass, we would have to round off to 2 decimal places. Let's hold on here. Let's hold on to this value so that we can have a more precise value when we get to the end of our problem. So we know that our density is 0.94 grams, and what we need is volume in liters, right? Because the question says, how many liters of fat? So density is mass over volume. Our volume is going to be mass over density. So we have our 1,818 grams divided by 0.94 grams per milliliter. And our grams cancel out, and we end up with 1934 milliliters, 1,934 milliliters. We're going to convert that to our liters by the conversion factor of 1 liter divided by 1,000 milliliters. Or alternately, we can move our decimal place over 1, 2, 3 to get the number of liters from milliliters. Our answer has to have 2 significant figures. Why? We started off with 2 sig figs, so our final volume should have 2 significant figures, and we have 1.9 liters. This concludes our topic for Unit 1.